All right, section 3.6, and we're going to prove theorems about perpendicular lines. The first thing that we're going to talk about is that if two lines intersect, to form a linear pair of congruent angles, then the lines are perpendicular. So what all of these notes are going to be about is that we're going to have just different kind of scenarios, and if these scenarios happen to be true, then we are going to be able to conclude that the lines are perpendicular. So let's read that one again. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So basically, the kind of situation we have here is that we're going to have, we have a line, okay, and it's, here we go. All right, so we have here, we have a linear pair, and we have an angle here, angle 1 and angle 2, and these angles are congruent. So basically, we have two lines that intersect. We'll call this line A and line B. So there's our two lines that intersect. They intersect to form a linear pair, and the two angles are congruent. So remember, what you know about a linear pair is that they are supplementary. So if you add the two together, they're going to equal 180. So this is saying if you have a linear pair and both of these are congruent, well, if this one, that means this one has to be 90 and this one has to be 90, because 180 divided by 2 is 90. Then if both of these are 90, then you can conclude that the lines are perpendicular to one another. So the way you write that in an if-then statement is saying is that if the measure of angle 1 is equal to the measure of angle 2, then line A is perpendicular to line B. All right, so the second scenario you have is if two lines are perpendicular, then they're going to intersect to form four right angles. And we've kind of briefly talked about this. So we're going to have two lines . So if our two lines, if they're perpendicular, so if they're perpendicular right there, so we can have, here's line N, and we'll make this line M. So if they're perpendicular, and we've kind of briefly discussed this before, if you have one right angle, then you can go ahead and conclude that you have all four right angles. So if you have two perpendicular lines, then you have four right angles. So if line M is perpendicular to N, then angle 1, angle 2, angle 3, and angle 4 are all right angles. The next scenario we have is that if we have two sides of two adjacent acute angles and they are perpendicular, and again, let's just kind of write this and then we'll discuss about what it all means and how to draw it. So you have two sides of two adjacent acute angles are perpendicular, then the angles are going to be complementary. So let's see here. Two adjacent angles, they're acute. Two sides of the adjacent angles are perpendicular. So basically, we have two angles. The sides of them are perpendicular. So basically, you're looking at, okay, this is one side of an angle, this is the other side of an angle. These are two acute angles. So we have like angle 1 and angle 2. So if we have this scenario in angle 1 and angle 2, then basically then these two angles are complementary. I mean complementary, remember again, that means that they add up to 90 degrees. So let's give this angle a name. So this is going to be A, B, and C. So basically, if side AB is perpendicular to side BC, then angle 1 and angle 2 are complementary. The next is if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. And again, we briefly discussed this a little bit. So in this scenario, we have two parallel lines. So here's one, here's another one. We have two parallel lines. And what's happening is that we have a transversal coming through. Okay, a transversal coming through. If the transversal, so let's get some lines here, 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 here we go. So if the lines are already parallel, and we know that this transversal is perpendicular to one of the lines, and we'll just give this T, we'll say this is A, this is B, then it's also got to be perpendicular to the other line. So remember, that kind of makes sense because this angle is 90, this angle is going to be 90 because these are corresponding angles and we know their measures are congruent. So if A is parallel to B and if line T is perpendicular to line A, then we also know that line T is perpendicular to line B. So if it's perpendicular to one line, it's perpendicular to the other. The last scenario we have is in a plane if two lines are perpendicular to the same line, then they are parallel to each other. So basically, this is our last scenario. We have two lines are perpendicular to the same line. So let's kind of draw that out. We have two lines. They're going to be perpendicular to the same line. So two lines are perpendicular to the same line. Let's give those some names. So we'll name this one M, this one N, name this R. So, and again, this kind of goes back with the same other scenario. We have, if this one's 90 and that one's 90, well, again, those are corresponding angles. So if you have corresponding angles that are congruent, then what you can conclude is that these lines are parallel to each other. So if line M is perpendicular to line R, and if line N is perpendicular to line R, then you can conclude that line M is parallel to N. Now, I know that was a lot of drawings and a lot of situations, but it actually applies to the questions a lot easier. So let's look at the theorems, let's apply them, find the measure of angle 1. Well, what this one is wanting you to apply is if there's one right angle, then you know there's four right angles. So all of these other ones are right angles. So to find the measure of angle 1, all I have to do is 90 minus 38, and what is left is 52 degrees. That's the measure of angle 1. That's how all of these long outdrawn definitions and drawings come into play. Again here, so this one is all about if you have two acute angles that see how these sides are perpendicular. Well, if the sides are perpendicular, then these two angles are complementary. So to find the measure of angle 1, 90 minus 65, measure of angle 1 is 25 degrees. Number 3, find the measure of angle 1. Well, this is the same scenario. Here, if you have this is 90, then you have all fours 90 degrees. So the measure of angle 1 is equal to 90 degrees. Alrighty, number 4, in the diagram, it tells you that FG is perpendicular to GH. So right here, perpendicular. Find the value of X. So here we go, find. Remember that word find means you're an equation creator. You have to think about how can you set up an equation that will allow you to solve for X properly. Well, we just learned that if lines are perpendicular right here, then these two angles become complementary. So that's the equation you're going to set up, that these two angles are complementary. And then you're going to go and solve for x. So you're going to combine like terms. That is 77. Subtract 77 from each side. So x is 13. Oh, not degrees, just 13. There we go. So your x is 13. All right, number 5, determine which lines, if any, must be parallel and explain. And we have kind of talked about this as well. Let's say, all right, we're trying to prove these two lines parallel, V and W. If we look at V and W, and we're just going to use Y as our transversal right now, we only have one angle measurement. We don't have anything over here. So these two cannot be parallel. If I use V and W and I try to test X as my transversal, I have no angle measurements, nothing. If I try to use X and Y as my parallel lines and V as my transversal, I only have one angle, not enough. Here I don't have enough angles. So no lines are parallel in this situation because you only have one angle measurement. You don't have anything else at these other intersections. Now here, if I'm trying to say, okay, are B and C parallel to each other? If I test this as my transversal, you have two 90-degree angles right here. Well, these angles add up to 180. These are consecutive interior angles, and what we learned about last time is if consecutive interior angles are supplementary, then the lines are parallel. So yes, B is parallel to C, and that is because you have consecutive interior angles that are supplementary. Now the last one, which statement must be true if C is perpendicular to D? So if C is perpendicular to D, then what we know is that these two acute angles are complementary. So let's see here. It says measure of angle 1 and measure of angle 2 equal 90. Yes, we know that's true. Measure of angle 1 plus measure of angle 2 is less than 90. Nope. 1 plus 2 is greater than 90. Nope, cannot be determined. We do know that if it is perpendicular, then that means 90 degrees.